How you doing? This is Argon here for the pH lab for honors and AP chemistry. One of the first things you can do is get your computer on, Google pH color chart, and then I went over and I chose, I think I chose this one right here. I copied it into Word, made it bigger so I could use it to hold the papers up against the screen of my computer when I was testing the different solutions. I want to talk to you briefly about pH. pH in French is something like puissance de hydrogen, something like that. And it basically means the percentage, or literally means the essence of hydrogen in something. Or it can mean like the percentage of hydrogen ions in a solution, or hydronium. H3O plus, hydronium, and H plus in solution are identical. Let me get rid of this. I'm supposed to be opening, not saving something. Alright. So anyway, the pH is a measure of the concentration of hydronium, H3O plus ion, or H plus. Those are identical. There's a formula for figuring the pH. It says pH is equal to the negative log of the concentration of hydronium ions. For example, if the pH is 4, it means that 4 is the negative log of 10 that will give you the concentration of hydronium. In fact, that's how you read a logarithmic equation. It's read like this. pH is the negative exponent. A log is an exponent. The base here, when it's not written, is 10. So pH is the negative exponent of 10. And that negative exponent of 10 will give you the concentration of hydronium ions. If the pH is 4, 4 is the negative exponent of 10 and will give you the concentration of hydronium ions, which is what I've read or written right there. And it simply means 1 times 10 to the negative fourth, which is 0.0004. You can go the other way. If you have a concentration of hydrogen or hydronium ions, they are identical. Let's suppose you have a concentration in a solution of 0.0035 hydrogen ions or hydronium. Then the pH is the negative log of the concentration of hydronium. You put in the concentration, 0.0035, take the negative log of it, and you'll find that the pH is 2.4559. If you take 10 to the negative 2.4559, you will see that you get 0.0035. Give it a try on your calculator. So that's a little bit about pH. Going back to our chart here, I took several different solutions. For example, I had cider vinegar. I took its pH and it was a 4. I've got some 409, cranberry juice, acetone. Acetone is nail polish remover. I've got some Lysol disinfectant cleaner. I have black olive juice. Black olive juice. I've got Shiraz, some wine. I have cranberry juice. I have some Febreze household freshener. I showed you the cider vinegar, I believe. I've got some soft soap from the bathroom. It is a pH of, what have I got here? pH of 4. I've got Windex. That was a little bit of a surprise to me. It's a pH of 8. Here I've got balsamic vinegar. I wanted to try 2 different vinegars, see how close they were to the pH of vinegar. I got some body splash. I got that from Xenon Warrior Princess. She's the chief chemist in the house. I got some H2O2, of course, hydrogen peroxide. I've got Listerine. There you go. Freshen up every morning with that stuff, why don't you? It sucks. That's a 5. I got some isopropyl alcohol. That'll give you an idea of what you're supposed to be doing with this pH lab. You're supposed to take different solutions around the house, take their pH, record them. If you want to do some calculations to practice the pH equals negative log times the concentration of hydronium, you can do that. I want you to use the papers like this. You just need a short paper like that. Dip it into the solution. Let it change colors. In fact, sometimes it's good if you let it dry. When you hold it up to the screen, the color doesn't show up necessarily as good as when it's dry. Okay, but you can hold it right up to the screen, and you'll get a fairly accurate reading. If you're not very good with colors, I'm not very good with colors, so I asked Xenon Warrior Princess see what she thought, and took her opinion. She's better with colors. When you're finished with this stuff is safe to throw down the drain. And of course, if your chief chemist in your house says that's ridiculous, then you don't throw it down the drain. Put it in the toilet. If she says it's not safe for the toilet, then throw it outside. If you rinse these cups well, you can reuse them for the next lab. If you have any questions, you know where to call me. Give me a call. Make sure you do this neatly, thoroughly, and make sure you have your materials, your procedure, and your results written very, very clearly. Thank you very much, and I'll be seeing you. Happy 4th.